Hello POC viewers, welcome to another video with your POC Guru. In this video, I will show you how to publish and receive messages from Kafka in your Spring Boot application using Docker, Maven and IntelliJ. A quick background on Apache Kafka. Apache Kafka is an open source distributed streaming system used for stream processing, real-time data pipelines and data integration at scale. Producers that generate streams can publish to Kafka and consumers can read from Kafka by subscribing to it. Kafka in its distributed cluster mode is usually managed by Zookeeper. Today we are going to run Apache Kafka in a containerized environment with the Spring Boot application. The Spring Boot application exposes a REST endpoint to publish messages to Kafka and also a consumer to read the published messages. For now, we will just print the published messages to the console using the logger. So let's get started. Start by opening IntelliJ and click on New Project. Create a project with a name like POC Spring Boot Kafka and click on Create. Now that the project is created, I will delete the default packages and create more meaningful packages like com, POC Guru, Spring Boot Kafka. I will add an app class with a main method in it. Don't forget to like, share and subscribe for more videos. Open the pom.xml file at the root of the project. As I am going to use Maven with JDK 11, I will update the source and the target to 11. Add the Spring Boot parent block and also the dependencies for Spring Boot and Spring Kafka. Also, add the build plugins to build a standalone jar with all the dependencies. Pay attention to the qualified path and the output file name which will be used when building the output jar. Click on the Maven tab in the top right corner of IntelliJ and refresh all the Maven dependencies. All the jars should now be downloaded to IntelliJ. Now that all the dependencies are downloaded, go to the app class and add the Spring Boot application annotation. Add the Spring application.run call in the main method to start the application. To use Kafka in Spring Boot application, we will create 4 configuration files: a consumer config, a producer config, admin config and the app config. Create a new config package and add a new Kafka consumer config class annotated with the @configuration. To the Kafka consumer config, add a bean that returns a map of string and object. This map holds all the basic information for the consumer to use. Create a consumer factory bean and wrap these properties in that bean. Wrap this consumer factory in a Kafka listener container factory. This creates a thread-safe environment for the consumers. From the consumer properties, you can already see that we are connecting to a Kafka on port 9092 and we are using a string deserializers to deserialize any messages that we receive from Kafka. Now that we have the Kafka consumer config ready, we need to create a Kafka producer config to push messages to Kafka. Create a file Kafka producer config and annotate it with the @configuration. Create a method that returns a map of string object with the configuration parameters. Wrap it into a producer factory using the default Kafka producer factory class. Create a Kafka template bean that wraps this producer factory. Pay attention to the properties of the Kafka producer. You can see that we are connecting to Kafka on port 9092 and also using the string serializer for the key and the value. Kafka template is a thread-safe template to send messages to Kafka. We are going to auto-wire this in our REST endpoint. Now create the third configuration file called the Kafka admin config. This is an optional configuration file you need to create if you don't have any topics. As I don't have any topics in my Kafka setup, I am going to create this configuration file. I'm going to create a bean called new topic, which will create a topic in my Kafka setup. I'm also going to create a bean of the Kafka admin with the specific configuration parameters to point to my Kafka on port 9092. If you have your Kafka and topics already set up, you can totally skip creating this configuration file. Now we create the Kafka application configuration file where we want to store all the application specific parameters. Don't forget to annotate this with configuration and also enable Kafka, which enables this Kafka in Spring Boot. Now that we are done with configuration, we need to create a consumer. Create a new package called consumer and add a new file to it called the Kafka consumer. Annotate the class with @component and create a method called process message which returns void. Annotate it with Kafka listener. Add a logger statement to this class to log all the messages that we consume from Kafka. Don't forget to like, share and subscribe for more videos. Enhance the Kafka listener annotation by adding the topic, group ID and the container factory. For the container factory, update it with the correct method name by choosing it from the Kafka consumer config. We are done with the Kafka consumer. Now let's get to the producer. Create a new package REST with a new class Kafka producer REST controller. Annotate this class with the REST controller and add a post mapping to this class. Add a logger so that we can actually log an incoming message from the REST endpoint. Auto-wire the Kafka template that we created in Kafka producer config and use the send method along with the topic name and the message to publish messages to Kafka. Now that we have the producer in place, let's create a Docker file to build our application. Create a new file with the Docker file in the root of the application. Add the Maven as build line and import the Maven layer. Create a workdir in the Maven layer and copy the project to this workdir. Run the Maven clean package command on this workdir. The output jar is created and is in the Maven layer. Add OpenJDK layer and set the workdir as /app. Copy the output jar from the Maven layer to the /app directory in the OpenJDK layer. Add the entry point to launch the application. Now to launch Kafka and Spring Boot in a containerized environment, we need to create a Docker Compose YAML file. Docker Compose allows to launch multiple containers in a single command. Create a new file docker compose.yaml at the root of the project. Add the version, the services as Zookeeper, the image for the Zookeeper and expose the port 2181. add Kafka, the image for Kafka, and expose the port 9092 to the external environment. Add the advertised host name and the advertised host connect for Kafka and Zookeeper respectively. Add the SpringBoot Kafka block to the Docker compose file. Use the build directive to build the image every time we want to launch the containerized environments. Now that the Docker compose file is ready, let's open the terminal and run docker compose up command. This will bring up the containerized environment. You can see Kafka, Zookeeper and the Spring application up and running. Open the terminal and trigger the curl command to publish a message to Kafka. You can see in the logs that the message has been received by our Kafka consumer. If we scroll up, we should be able to see that the message was produced using the REST endpoint. That's it, POC viewers. Publish and consume Kafka streams with Spring Boot, Docker, Maven and IntelliJ under 12 minutes. Like, share and subscribe for more videos.